In this lesson, we're going to talk about all the wonderful ways that we can use the knowledge that we already have about our quadratic functions and apply it to some real world situations to see how quadratics can really help us understand different situations. Before we do any kind of application stuff, I think it's important for us to just kind of review and recap all of the key features that we've talked about throughout this whole unit. So first, the vertex is always the highest or lowest point of our function. The axis of symmetry goes through that vertex point and cuts the graph into two halves. Our y-intercept is where we cross the y-axis. There's four words that we can use for where we cross the x-axis. Those are roots, zeros, x-intercepts, or solutions. Then we also have a maximum or minimum value, depending on whether the graph is opening up or opening down. And that's just the y value of our vertex. So axis of symmetry takes the x value, and the maximum or minimum would be the y value based on our vertex point. So quadratics can actually help us model a lot of different situations in the real world. First, if you think about like throwing a ball or anything that gets dropped, it makes that parabolic path that we call it, makes a quadratic shape. Businesses can also use it to figure out what price they want to sell their item at, because that'd be at the vertex point. That's the maximum value. And even area optimization. So if you're trying to figure out how big to build something to maximize the area with inside, you can use quadratics. I really like this example on your screen. It shows a angry bird. Even when you shoot it off a slingshot, it will also make that quadratic path. So it ends up being one of my favorite games because I get to use some math whenever I'm playing video games. How exciting is that? So quadratics can be useful for video games, but they can also be really useful in sports. And so we're going to look at an example of that. We've got Texas Tech legend basketball player Jarrett Culver, the Lubbock native. He's shooting a big three-point shot to win a big game. He's shooting the ball from 24 feet away, and the path of the ball can be modeled by this. So x is going to be our horizontal distance from the hoop, and f of x, or my y, is going to be the ball's height. And so we want to know all of these key features to learn about his shot here. So I'm going to go ahead and pull up Desmos here. When I do that, I've already labeled my y-axis as my height and my x-axis as my horizontal distance. And so the first question asks, how high is the ball above the ground, or how high above the ground was the ball released? So it's asking for a y value here because we want the height. And so if I go ahead and type in the equation, we get this graph, this parabola, and that's this equation here. And so we want to know how high above the ground was the ball released. Well, we know that if we're shooting, the ball is going to be going forward, right? So we're not going to have any kind of negative distance. So I'm looking at what point does the ball start traveling forward. And that's going to be right here at my y-intercept, because after that, the ball is shot and it's moving forward towards the hoop. And so I see that's 7 feet above the ground. My y value there is 7. So I'm going to show Culver there. How high above the ground was he? Well, he was 7 feet above the ground when he released the ball, or the ball was 7 feet from the ground. Question 2 says we want to know the maximum height of the ball. So the maximum height is the highest point that we reach, right? And remember, our vertex is always the highest or the lowest point. This parabola and a lot of these application problems are going to have parabolas that are opening downward. So I can click on the vertex and I can find my x and my y values. So my y value here is my maximum height. Again, height is my y-axis. So I'm looking at the y value of my vertex, which is my maximum value, we call it. So in this case, the maximum height was 11.69 feet. If we round to 2 decimal places, 11.69 feet above the ground was the maximum height of the ball. And so question 3, we want to know how far away from Culver was the ball when the maximum height was reached. So now we're thinking about a horizontal distance at its maximum height. Well, that's still going to be my vertex, just now my x value, which in this case is just 15. So we can say the ball was 15 feet away from Culver when it reached that maximum height. Last question is we want to know if the hoop is 10 feet tall. 10 feet tall, did the ball go through the hoop? And so we're looking for a specific point. We are given, in this case, a y value. It's 10 feet tall. So what I can do is I can type in y equals the value 10 because that's how high I know the hoop is. And so I see the two solution points when we talked about our systems unit, our quadratic and our linears. Whenever they cross, they meet at two places. And so I've got two solution points here. One of them's at 610, and one of them on the way back down, the ball is at 2410. And if we remember, he shoots the ball from 24 feet away. So if it's going to go through the hoop, it would have to be at the point x is 24 and y is 10, which we see in this case. 2410 is a point right on that graph. So the ball is indeed going through that hoop there. So we can say that, yes, Culver did score because the graph passes through the point 2410. So Red Raiders win, Jarrett Culver scores, everyone is happy. And so these are just a couple ways that we can apply our knowledge of quadratic functions to some real world applications. If you're trying to get better at basketball, I would make sure that I'm studying up on these quadratics. But anyway, I hope you had as much fun as I did with this lesson. Good luck in your practice, and I'll see you in the next video.